So, good afternoon and welcome to this data center facility project workshop. My name is Mark Dancy. I'm the OCP Ready lead for the OCP Facility Recognition Program. And I'll be talking to you today about how a colo solution provider can have their facility branded OCP Ready. I'm also joined by Andy Long, the strategic advisor for Hydro66, and he'll be sharing with us their experiences with applying for and for attaining the OCP Ready status for their facility in Boden, Sweden. So, what is the program? The program was created to allow for a colo solution provider to show their readiness to deploy open racks and IT gear. By being an OCP Ready facility, it means that both a data center operator and also an OCP user can take full advantage of the cost savings, the energy efficiency and resource efficiency savings that can be achieved by deploying OCP technologies. So the guidelines, guidelines were created by the data center facility project team, and these guidelines were to be able to give the sort of fundamental facility requirements for a data center operator and for an OCP user to understand what it is required to deploy OCP open racks and IT gear. The colo facility guidelines contain details about the OCP racks and hardware, and also highlight the differences between the deployment of EIA racks and open compute racks, and also the fundamental differences between the two different deployments. So, why does this assist end users and also colo solution providers? And why was it created? 3 years ago, the OCP Foundation were getting feedback from OCP users that they were finding difficulty in finding suitable facilities. The issues that they were finding was things around weight loading capacity wasn't sufficient for fully populated racks that could weigh upwards of 1,500 kilograms. They also couldn't find the power capacity required for the minimum 6.6 kilowatts required for racks. So there were issues around finding suitable facilities. So that's the reason why the Data Center Facility Project was asked to get involved with creating the guidelines. So for colo solution providers, the benefits were around we have a checklist which enables for a colo facility provider to easily understand what they require to host open racks and IT gear. So one thing, it helps the colocation provider understand what is required, but also for the OCP user, it helps them review the attributes of a colocation facility to find out whether it is suitable for their requirements. So how does a colo solution provider become OCP ready and have the facility given that status. So the first step, and if you're already a platinum, gold, silver, or community member, then you can enter the process right away. But if you're not a member, you will need to become a member at one of these levels. Step 2, you need to download and review the co-location facility guidelines, and then download the site assessment, which you need to fill out. And you can see straight away whether your facility is compliant with the requirements of the data center facility project. When you've completed the site assessment, that needs to be sent to myself and also the project lead, and then we initially review that assessment. We ask for any qualification or additional information. And then we arrange for you to present that facility at a monthly project call. And that's when the community has the ability to be able to ask any questions and find out more information. And as a colo, you can then give some information about your facility. Once that's been done, it then goes through to the incubation committee for their review as well. In parallel with this review process, you also need to execute 3 agreements: the copyright license agreement, the colo solution provider agreement, and also the OCP Ready certification. Once those agreements have been executed and the IC have approved your facility, then it can be listed on the marketplace. And also you would become listed as an OCP solution provider in the directory. So just to go through what the marketplace looks like. So there's 3 filters within the left-hand pane. We have the status of OCP Ready, the category of facility, and then we have the 4 current OCP Ready data centers under the filter of solution provider. And currently we have 3 based in the EMEA and 1 in North America. Once you access the facility through that marketplace listing, each facility is able to have photos of the facility displayed, a brief description from a marketing perspective, also contact details of the facility and the organization, the colo, and also you can have a look at the site assessment. And here's some examples of our 4 facilities. So just to give a little bit of information about the current OCP Ready facilities. So KO Data were one of the first 2 facilities that went through the pilot program with Rackspace. So they're based in the corridor, the London, north of London, in the London Stansted Cambridge corridor. It has 4 suites, providing 860 square meters of space within each suite, 2.2 megawatts per suite. And their indirect adiabatic cooling can meet ASHRAE recommended and allowable standards, and they have been able to achieve lower than 1.2 PUE. We have rack space, as I'm sure you're aware, one of the founders of the OCP. And that facility is in Crawley, in south of London. That's got a white space area of 6,600 square meters and a power capacity overall of 12 megawatts. And they're able to support racks up to 16 kilowatts in IT load. And also they can achieve 12 degrees delta T. So that's, they're able to meet some of the optimum requirements of the OCP Ready site assessment. And Giga data centers, they're our only North American data center at the moment. We're looking for more to join them. They're slightly different to the other facilities in that they provide modules for their users, and those modules, they can accommodate up to 52 racks at 40 kilowatts per rack, and they have sort of a fairly unique cooling system for that, to achieve that. So I'd like to welcome Andy to the floor, and he's going to talk about their facility and their experience being part of OCP Ready.
Thanks a lot, Mark. So hi everybody, my name is Andy Long from Hydro66, and that is our beautiful data center. That is quite an old picture now, when we only had 6 megawatts. We're up to 19.2 megawatts now. And people sometimes ask me, Andy, what does Hydro66 mean? It's a very cryptic name. The hydro is fairly obvious. It's for the hydroelectric power that we use. The river that we're on, the Lule River, which is the same river that powers Facebook in the north of Sweden, has 4,300 megawatts of power on it, of which we're using 20 and Facebook's using, I think, 200. But the 66, what is that? Well, we're actually pretty north. We're actually at 65.8 degrees north. So we rounded it up. Also, Hydro 65.8 sounds a bit like a radio station, so we get less confusion with that. And there's a view inside the DC there. The reason it's red, one of the traditional industries in the north of Sweden is actually iron ore mining up in Kiruna, where the ice hotel is. And the Swedes like to recycle, circular economy. So you take the waste product from iron mining and you turn it into a treatment for building exteriors. And that's what that is. That's why it's red. It's actually rusty. But it's very good at protecting us from 30-degree cold in the winter and 20-degree warm in the summer. So this is where we are, up in the north of Sweden. I carry a map of Sweden everywhere I go. There it is. There's Stockholm, there's Luleå, that's Norway, and this is Finland. And Facebook are our close neighbours. Facebook are 20 miles down the road in Luleå. And actually, Facebook is the reason that we are up there. It's how we found the site. My colleague Paul was, I think, reading an article about the Facebook deployment there when we were looking for a site to disrupt. It's the same team that disrupted telecoms with EasyNet in the 90s and 2000 before we sold that business to Sky. And we wanted to go somewhere that was cold, that had renewable power, and that was fun to go to as well, because nobody wants to just sit there in the dark and do nothing. And we read about Facebook, and we actually first became of OCP in 2015. When we 2014, when we saw Facebook's original deployment, and we thought, well, hey, if we build next to Facebook and we do colo economics Facebook economics for colo, we should advertise ourselves as Open Compute Ready. Well, only 5 years later, we've achieved that. There wasn't actually an Open Compute Ready program at that point, but we anticipated it before it even existed. So there's the site today. We've added the lines. The lines aren't there in reality, but there's 19.2 megawatts, and each of these halls is between 2 and 4 megawatts. And the reason we've split it out like that is so we can have a different specification per hall. So some of our customers, high-end customers, enterprises, want dual power feeds. They want UPS. We use flywheel UPS because that's more environmentally friendly than batteries. Svenguel in Swedish, Tor, I think that's right, Svinghjul, flywheel, yeah, good. So that's this one here. And then we have high density 20 kilowatt racks, single power feed for super dense customers. But if you look at it from the air, it is almost like a heat sink, which in the end is one of the core functions of a data center, right? It's to dissipate heat. And I did some research, what was the very original first data center in the world? And it was in Bletchley Park in the 1940s when we were trying to break German encryption in the Second World War. And the first programmable computer, which was invented by Bill Tutt and Tommy Flowers, who were not celebrated at the time. And if you Google them, find a BBC documentary called The Secret Heroes of Bletchley Park. It's fascinating. But they needed somewhere to put these Colossus machines in. It's two spinning tapes comparing to bit streams and essentially looking for patterns. And so they built a room per Colossus, 6 kilowatts each. And they had a corridor between the rooms. And from the air, it looked very much like a corridor with rooms like that. So nothing much changes. That's a 1944 data center design. But we love it. We can get 40 megawatts on that footprint. And then next door, there's another 40 megawatts we can do. So we're not going to run out of power anytime soon. And inside, there's a lot less M&E than you might expect in city center locations. Why are all data centers in Frankfurt, London, Amsterdam, and Paris, mainly in the EU? It's because telecoms used to be super expensive. And so everybody would locate near the IXPs and not have to go and spend tens or hundreds of thousands of pounds and euros on interconnect for telecoms. But telecoms is cheap now. We can get 10 gig across Europe for nothing. So much better to go to where the power is cheap and where the air is cold. So we literally just take in the air from the top there, spin it through some fans, into the cold airs and out through the servers. Now, in winter, minus 30 degrees, not so great. As John mentioned yesterday, if you hit a wet pad, it's doing the humidification with minus 30 degree airs, it's going to freeze like that. So instead what we do is we recirculate some of the air, reusing that heat to bring the 30 degree minus air back up to a set point of 18.2. So we have no DX expansion, we have no external chillers, and that gets our PUE down from what's on-prem, two times PUE, efficient 1.5 PUE, Equinix best case for DX indirect is 1.2 PUE. This data center, which I think is why we won the DCD award last year, is 1.07 PUE, and it's 100% renewable. So using the cold air that's already there, rather than spinning warm air around and cooling it down again, makes a lot of sense. So the OCP Facility Recognition Program, it involves a spreadsheet, actually a G sheet. And we found the process actually really simple. I want to thank Mark for his help with that, and Brevin for telling us about the program when it was in its initial phases. And it's essentially a case of going through a checklist to give customers confidence that there will be no issues when they turn up with 1 rack or 20 racks or 200 racks. So each of these questions, as you go down, it says, well, what's the power receptacle like? What is your floor loading like? What is the maximum height of your door? What is the loading capacity of your lifts? To make sure that when you turn up with a 1.6 ton fully loaded OCP rack, ideally from IT Renew, so that you've got a 0 kind of CO2 footprint on day one, you're not going to have any problems installing it. And the simpler your data center design, and I would encourage any operators that are here that aren't in the program yet to apply for this, because we should all be showing support to the OCP program. The simpler the design, the easier it is to comply. Do our elevators, do our lifts comply with the minimum loading requirements? Yes, they do, because we don't have any lifts. Can our raised floor handle the weight of a fully loaded OCP rack? Yes, because we don't have any raised floor, it's a concrete slab. The simpler the design, the easier it is to comply. So we first started talking about being part of this program in August 17. I was here in 2018, and we applied actually once the spreadsheet was opened up to the community properly in Q2 2019, and I found it a really easy process. So you go through the spreadsheet, and as Mark described, you do a call with the Rack and Power group and take everybody through essentially each item on the spreadsheet and say, well, look, this is our facility, any questions? And then it goes to a secret vote. Everybody gets asked, like, do you approve of this? I'm like, oh God, have I been nice to everybody last year? but it's fine. So great support from the team, and then once you are approved on the site, on the marketplace, we can have a link. So this is our landing page, and click through, find out about being an OCP client of Hydro, and it's a very, very, very simple process. So I'd like to talk now about the technicalities of physically dotting the I's and crossing the T's. As Mark mentioned, you have to complete the membership agreement. We're a community member, and go through the site assessment, been through the approval, and then you get the approval to use the logos and so on, and also upload our logo and pictures for the marketplace. So that's all live, and it was like a process of a couple of days once it was all approved. You can even sign the agreements electronically. We are truly in the future. So you're an approved colo provider, and you find your first customer. And again, working with IT Renew and with Nexity, we found a customer really quickly for a really interesting and exciting product called Rapid Space. If you're not aware of Rapid Space, I'd encourage you to come to the stand downstairs and ask one of the team about it. It's an absolutely fantastic way of deploying dedicated machines very quickly, very simply, at a price that is frankly quite shockingly low. So practical issues. One of the things that isn't in the OCP Colo standard, or indeed the ORV1 rack standard, is the maximum height of a rack. You can have a compliant ORV1 rack that is 150U. And it would technically be an OCP rack. Nobody manufactures them, but just to be aware. So we want to check, what's the size of the crate, what's the size of the rack, is it okay? Happy days. Make sure our security are expecting a large crate, and also just confirm any non-standard equipment. People still sometimes want to use some 19-inch or non-rack mountable switches or monitoring gear, everything CPE. So check all that stuff, make sure the uplinks are the right optical standard. And there's the Rapid Space product I mentioned. If you go to rapid.space, you can find about it. And we're very proud to be supporting that with our facility in Sweden. But people always wonder about, I'm going to deliver this 1.5 ton rack, how simple is it going to be? Am I going to have issues? And so we thought, actually, a picture or moving picture is worth 1,000 words. So we decided to film the process of the delivery of an OCP rack into a data center, and how simple is it? We thought about doing it live, satellite link, but the rule of tomorrow's world technology demos, we filmed it. So let's see if this plays automatically, or I have to click it. I shall click it. Here we go. It does look like a heatsink, right? So look, for sure, there are massive environmental benefits in reusing hardware and recertifying hardware. The racks are coming out of Facebook and Luleå. They're going 5 miles down the road to be recertified, remanufactured, and coming 20 miles up the road to us. You've heard of food miles. Well, what about server miles? But as well as the CO2 impact, think about the time involved in deploying a new rack of your own tin. and 40 server boxes or 20 server boxes turn up, and an expensive techie has to go and unbox every single rack and pile them up and get rid of the cardboard and get rid of the polystyrene and plug them in, and then realizes they don't have the right switch with them or they forgot the line cards. If you've got a pre-certified, pre-working rack, how much quicker is it to deploy new technology at scale? I had some feedback on that video, said I didn't show the servers enough, so we did a second version that's got less data center and more server. So I'm going to show you that. It's coming. All the best IT has flashing lights, that's my view. There we are. The call to action is to join the OCP project and to get involved in being a colo, an OCP Ready trademark colo provider. Join the organisation, speak to Mark or one of his colleagues about the checklist, do an initial evaluation yourself to make sure that if there's anything you need to change, and then complete it and submit it. Mark's contact details are up there, as are mine, if anybody's got any questions. But it's a pleasure to have been here presenting and with Mark. And I don't know if anyone's got any questions, or if Mark, you want to have any discussion.
I think thanks very much for that. It's really, really informative and a great example of what we're looking for to make it really easy for OCP users to adopt OCP.
Yeah.
And to be able to just bring those racks in really quickly and get those systems up and running really in a very quick time. So yeah, that's a perfect example. I think one of the other things that I found when I visited Luleå, and I didn't really understand some of the other benefits around that area, but it's the power quality and availability as well that astounded me. I just wonder if you can.
Sure, that's a great point actually. I mean, the other reason that the whole Uptime Institute tier standards have evolved is that when you build data centers in city centers, because they're so dense and because there's not a great amount of overhead in the power in the centre of London or in the centre of Frankfurt, the power that you get isn't that reliable. It'd be dirty, you get dropouts, you get kind of frequency shifts and so on, and that's why everybody in the industry for 20 years has had this kind of obsession with UPSs and 2n+2 generator sets, and there is embedded carbon in all of those bits of infrastructure. There's embedded carbon in the tank full of diesel that you then have to replace or polish every year. And so if you can go somewhere where you're next to the generation, to the reliable generation, so the river doesn't stop flowing. The Swedes don't do things by half. I think they got a deal on a job lot of concrete in the 50s because they built way too much generation up in the north. The first high voltage distribution line in the world was built from the north of Sweden to Stockholm to carry some of this power. The biggest power station on the Little River at Harspranget is 980 megawatts. So to put that into perspective, CBRE's figure for all of the colo in Frankfurt, London, Amsterdam and Paris is about 950 megawatts. So you have one dam that's producing the same amount of power as all of these megabucks data centers are using. So what we found is actually rather than taking one maybe unreliable feed and then bolting a generator onto it, and bolting battery power UPS onto it and replacing the batteries every 3 years or whatever it is these days for sealed cell. Well, why not just take two feeds from two different dams and two different substations and distribute them all to every rack? So every one of our enterprise racks has got a blue feed and a red feed. And red means UPS and north, and blue means no UPS and west, I think, coming from two different substations. And that way, with our dual UPSs, even if there's a blip on one side, everything stays powered up. And if there's a blip on the other side, the flywheel takes care of it. Compare that with the track record of the industry in running critical facilities that are backed up by UPS, genset, or worst of all, drups. Whereas if the gearbox goes, the whole thing's knackered. 85%, 90%, there's a figure around that of outages in those data centers which are finger trouble. You know, who feels excited when their data center manager says, I'm going to test the UPS tonight, or I'm going to test the generator tonight? When do the outages happen? Oh, well, you know, we forgot to turn on the automatic switching, and I'm really sorry about it, and it won't happen again, and then 18 months later, it happens again. So we're big fans of building in resilience rather than bolting it on. Yeah, just like putting load next to power instead of next to data, it's a lot cheaper and easier and reliable to move photons than it is to move electrons. And when you move power from generation sites, like in the north of Sweden, to other sites, then you get transmission losses as well. So, you know, city centre colo is not going away. There will always be low latency use cases, high frequency trading, flash boys, whatever. But as the load keeps increasing exponentially, I think we're going to see more and more enterprises and mid-scale cloud providers following the lead of the hyperscalers and going to clean, green locations. Yeah.
Thank you.
Excellent. Do we have any questions from the audience? Tor?
On the requirements side of products, is there anything on energy efficiency or on renewables? Is that out of question?
So it's not a must-have, but we do ask for that information to be provided around PUE, WE, CUE, whether you publish that online or whether it's something that is, you know, is on request. So it is something that we've considered. It's something that we're trying to promote, and this is something that we can develop further. We can put things within the considerations around heat recovery, for instance, and the guidelines and the site assessment is a dynamic thing that should be under constant review as we look to include advanced cooling solutions as part of the infrastructure. I mean, where you have air cooling seems to work best. It's very clean air, very low contamination, but that may not be the most suitable thing for something in central London. So,
and people's requirements differ, right? So depending on, there's how do you optimize things. So depending on the type of data center, putting your set point at a different level can make it more efficient or less efficient. If you speak to somebody doing indirect air cooling, they want as high a set point as possible, because when they spin their background, they have to cool it less. And there's efficiency gains instead of getting it all the way back down to 18. Whereas for us, the lower the set point, actually, the better. And for certain types of use, you want as big a delta T as possible. I've certainly seen RFIs that have specified a PUE must be 1.2 or lower to even respond to this RFI, and it must be 100% renewable. And, you know, I think we should also think about renewable and renewable. So if you are next to a renewable generation source and you're not getting transmission losses, I think that's better than being in, I don't know, somewhere where you are not close to the renewable and buying a certificate. Because when you buy the certificate, the windmill doesn't spin any faster. The sun doesn't shine anymore. So I'm not saying don't do that if you are in a kind of a dirty area, but even better, go somewhere where you're directly next to the real renewable electrons. Yeah. Any other questions? Sure, at the end there.
Wondering if there's any specification requirements coming out about the reuse of heat.
So the question was, are there any specification requirements coming out about the reuse of heat?
No, but we're definitely looking to have that as a sub-project in the future. So in the Advanced Cooling Solutions project, there are requirements being created, guideline documents for advanced cooling solution manufacturers to provide equipment that maybe, you know, outputs their, the liquid at a certain temperature. And then it's within the data center facility, what do we do with that? How do we connect it? How do we connect it in the facility so a facility can take any type of immersion or rear door or cold plate or on chip? We need to create some guidelines within the data center facility to help people understand what are the minimum requirements you could put into a facility when you don't know who's going to be knocking on the door, asking, to accommodate.
Yeah.
But we also need to go further with that, I think, with how do we connect the building to a district heating system? How do we connect it to a greenhouse?
Yeah. It's funny, Mark and I we were discussing this on LinkedIn this week, actually, talking about these different metrics. And I think, again, just like there's different sorts of data center and different scenarios and different geographies, there's a lot of different heat reuse scenarios. So, yeah, if I've got a data center in Amsterdam and there's a big greenhouse next door and they can use some 40-degree air, then happy days. That's very different to running a 1.8 PUE data center and then taking a heat pump and powering it with fossil fuel electricity to get the heat from low grade up to high grade so that it can be used. There's definitely some reuse that is more optical than sensible, and there's some that is sensible, and I think the whole industry should be open to engage with that and look at the use cases in each scenario. So some district heating systems need 120-degree heat. A swimming pool might need 50-degree heat to kind of take some of the load of keeping the water warm. So we should be open-minded, but we should also not be afraid to challenge people who just say, yeah, I'm reusing it, and educate them about the laws of thermodynamics and what makes sense and what doesn't.
Yeah, so we're definitely looking for contributions. We need people to come forward and say, yeah, we're interested in helping a sub-project in this area. So yeah, please contact me, anyone else in the project, and yeah.
And
great.
John, you had a question, I think.
Yeah, well, it might be a provocative question.
Love him.
You like.
Because you're referring to the LinkedIn post that I mentioned about PUE.
Sure.
When we talk about PUE, one of the things that we've come across with the prototype is there was a class called instantaneous PUE, which I think was in one of the Greek grid, PUE 0.
Yeah.
And now there are 3 classifications of PUE, as you know from the ISIS level. I think we should really make sure we know what kind of PUE we're talking about to start with. And there's an argument that says we shouldn't even be talking about PUE because it's a metric that should be used internally, not externally and to that point, there's been some research done on where best to locate data centers. This piece of academic research said the best place to put them is in West France. Okay, based on.
Was that written by a researcher in West France, by any chance?
I think it was researchers from. I'll look it up.
Yeah.
But one of the things they failed to recognise about northern Sweden is that they said that you need to expend energy to keep the incoming air from outside, which you're already reusing heat.
Yeah, exactly.
So we don't say much about that.
Yeah.
We don't say much about it.
There are no heating elements in our data set. You absolutely use the.
Recycle the heat.
Exactly. You take the exhaust heat, you spin it back round, and you mix it. So yeah, the idea of the PUE, if you were taking the amount of energy use wastage that you would waste if you were taking minus 30-degree air and then heating it up with resistive load to then put into your servers at 18. Yeah. Oh my God! Yeah, but that's that's classic academic versus real world. But but to your you should tweet. You should tweet that. So look, John. For those that didn't hear all of that, John's talking about PUE. There's lots of people who use different definitions, and there's internal load. And if you spin the fans in the server really fast, then it doesn't affect your PUE because it's all the boundaries, the PSU. And when different people use different metrics and different calculations, can we trust it? And it's absolutely right. In its purest form, it should be a measure for measuring your own improvement. Because as soon as I say we're 1.07, somebody else will say we're 1.06. But when you're comparing 1.5 with 1.07, even given the rounding, there's a big difference. And we should also call out people who say, yeah, we're a negative PUE data center because we've got 20 kilowatt, 5 kilowatts of PV on the roof. right? Naming no names NGD. That was, I think they've stopped saying that now. That was a couple of years ago. Look, I agree with you, John. It is what it is. It's not perfect, but while we've got some measure that people understand, we can talk about it. But I would encourage everybody to drill down when somebody makes the more extraordinary the claim. Ask for the data and ask what they're really doing, because it's obvious, right? If you're somewhere snowy versus Abu Dhabi, it should be easier. Which is not to say that you don't need data centers in Singapore or in North Africa or whatever, but we should all be working together and sharing our work into the OCP community and into the working groups to make things better. And there's also there's an efficiency in just in the management of a data center and using OCP kit. The grief that we've had from customers bringing non-standard equipment which doesn't have front-to-back airflow or has a strange shaped power supply or is like that, and you need to get the containment right get the containment right, because the better the containment, the better the efficiency. If you're racking up OCP, cores and using the Facebook pizza boxes, non-flammable, recyclable material printed on every one, it's a lot simpler. And the simpler it is, the better it is, and that's a rule that I think we can live by. Yeah,
and cost savings and efficiency gains. Are taken advantage of. So,
absolutely.
Yeah, very good. Very good.
How are we doing for time? We've got 5 minutes if anybody's got any more questions. If not, we can have coffee early.
I have one
Sure.
on the Colo Solution Provider Agreement. What is that? Or sort of what's the gist of that? I had 3 agreements. I could understand the other 2, but what's that?
Shall I talk them through it, all 20 pages? No.
So you need to be a Colo solution provider to be able to then have your facility branded OCP ready. So
that's what you sign up for.
That's what you sign up for. We have other solution providers within Open Compute that provide OCP hardware, be it network, storage, servers. So what we've done to try and differentiate facility from a solution provider that just maybe provides hardware. It's a separate thing for colos.
That's right. It lines you up for a small additional subscription, and it also governs the use of the term, and not to hold yourself out as being endorsed by Mark or by John, and not to make outrageous claims. So it's just a standard kind of we're part of this program. It's not expensive, and we're proud to be one.
Yeah. So if there's anyone here that's got contacts within Colo facilities that maybe they don't know about the program, be great to have an introduction. And what we need to do is really sort of grow this marketplace, make it easier for OCP users to find somewhere to house their OCP gear, and that means that adoption will grow, and it'll be good for all of us, I think. So, yeah, well, thanks very much for joining us today. And
This one.
Thank you.